Okay, so in question 4, where you have this polynomial long division, you're asked to find the dividend. There are two ways that you could go about that. One way is to focus in on this first line of work in the long division problem and recognize that when you take the first term in the dividend and you subtract 4x cubed, that canceled out and left a 0. So that makes our first term 4x cubed, because 4x cubed minus 4x cubed is 0. Okay, then similarly, the second term, the quadratic term, that came from when you distribute this negative, subtracting 16x squared, and ending up with a negative 28x squared. So that makes our second term a negative 12x squared, because negative 12 minus 16 is negative 28. Okay, then the third term, the linear term, that was dropped down from above in the dividend, and so that makes a positive 38x as our third term, and then similarly the constant of 600 dropped down from the dividend. And so our coefficients for the dividend, we would have a 4x cubed, the coefficient there was 4, then a negative 12x squared, so the coefficient there was negative 12, then 38 is the coefficient on the linear term, and the constant of 600. So you would have entered a 4, a negative 12, a 38, and a 600. Okay, when I looked at your answer, you put negative 44 here as the coefficient on the quadratic term, and that error is a result of forgetting to distribute this negative over the parentheses, right? If you were doing this strategy of working backwards from the first row of the work and you didn't distribute that negative, then that's what would make the second term negative 44, right? So your mistake there was forgetting to distribute the negative before working backwards. Okay, another way that you can do that problem rather than working backwards like we did here is the dividend is when the remainder equals 0, a product of the divisor and the quotient. So you could have also multiplied the divisor, which is a linear binomial x plus 4, times the quotient, which is a quadratic trinomial 4x squared minus 28x plus 150. And then when you multiply x times 4x squared is 4x cubed, then x times negative 28x is a negative 28x squared. Then we have x times 150, which would be 150x. Okay, then 4 times 4x squared is 16x squared. 4 times negative 28x is going to be a negative 112x. And then 4 times 150 is plus 600. Then we're going to combine our like terms. So 4x cubed plus 0 is 4x cubed. Then negative 28x squared plus 16x squared is negative 12x squared. Then 150x minus 112x is positive 38x. And then our constant of 600. And so you can see by that method, you also get the same coefficients of 4, negative 12, 38, and 600. Okay, looking at question number 8, which was marked wrong on the quiz. Okay, we're asked to find the remainder of x cubed minus 2x squared plus 3x plus 4 when the divisor is x plus 2. So if we use the remainder theorem, then we would be substituting a negative 2 in for each of these x's. So we'd have negative 2 raised to the 4th minus 2 times negative 2 squared, then plus 3 times negative 2 and plus 4. So that would be negative 2 raised to the 4th power is 16. Then negative 2 quantity squared is 4 times negative 2 is a minus 8. Then we have a 3 times negative 2 is minus 6. And then our positive 4. So 16 minus 6 is 10, minus 8 is 2, plus 4 is 6. And so then since f of negative 2 is equal to 6, 6 is the remainder.
6 is the
Okay, when I looked at your answer to this question, you entered negative parentheses 21
What did you say?
divided by
What did you say, Nina?
parentheses x plus 2. Okay, so not sure how you got the negative 21 there, but you wouldn't write the remainder as a ratio over the divisor. Okay, that would only come into play if we were asked to represent this quotient. So if we were in question 8, instead of being asked for the remainder, if we were asked to divide x plus 2 into that polynomial, then we would represent the quotient with our remainder over the divisor. So for example, if we had done the long division or the synthetic division, negative 2 would go into a 1, a 0, a negative 2, a 3, and a 4. Bring down the first term. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 2 plus 4 is 2. 2 times negative 2 is negative 4. 3 plus negative 4 is negative 1. 1 times negative 2 is 2. And 4 plus 2 is 6. So there you can see our remainder of 6, which was what this problem was asking for. And then the constant, the x squared, and the x cubed. So the quotient, if we were asked to represent the quotient of that division, would be x cubed minus 2x squared plus 2x minus 1 plus the remainder over the divisor. Right? That's where the remainder over the divisor comes into play. But question 8 was only asking us for the remainder when we're dividing x plus 2 into x to the 4th minus 2x squared plus 3x plus 4, and that remainder is just 6. Okay, then in question number 11, it says, according to the remainder theorem, if x plus 16 is a factor of f of x, then f of blank equals blank. So in the remainder theorem, we take the x plus 16 factor, right? That's x plus k in the remainder theorem. And we set that equal to 0, and then we substitute f of negative k, because when that's equal to 0, x is equal to negative k, right? And when we evaluate f of negative k, that's going to equal the remainder. That's what the remainder theorem says. So if x plus 16 is my divisor, then I'm going to substitute negative 16 in for my x's. So I evaluate f of negative 16, and the answer is going to be the remainder. Now it tells me that x plus 16 is a factor, And the factor theorem says that the remainder is 0 whenever we have a divisor that is a factor. So f of negative 16 equals 0 would be the correct answer. And when I looked at your work or your answer for that question, you entered that f of x was equal to negative 16. So you got the negative 16 part correct, but the notation doesn't make sense, right? The negative 16 is the k that's being substituted in for the x's, and because it's a factor, it's resulting in a remainder of 0.